Now this is kind of a design problem. We know what voltage we want. We want to have a 2-volt voltage drop with this polarity across this resistance, and we have a limitation on the current through that resistor. We want it to be less than 10 milliamps. Now if I do KCL at this terminal here, this current is the same as this current, so R1 and R2 are in series, and we know the voltage across the series combination. It's 5 volts. So we can use a voltage divider formula to determine what V1 is. Let's try that out. So V1 is going to be the total voltage, 5 volts, times its resistance, R1, over the sum of the resistances, R1 plus R2. Now we know we want that voltage to be 2 volts. So R1, if I divide through by 5, over R1 plus R2 is equal to 2/5. If I simplify this, 5 R1 is equal to 2 times R1 plus R2, or 2 R2 is equal to 3 R1. There's one equation and two unknowns, but I need to find another equation. I know something about this current I1. From Ohm's law, V1 is equal to I1 times R1, or I1 is equal to V1 over R1. We know that V1 is going to be 2 volts. We don't know what R1 is, but we do know we want that to be less than 10 milliamps because of this specification. So let's choose I1 equal to 1 milliamp. So 0.001 amp is equal to 2 volts over R1. This tells me that R1 is equal to 2 over 0.001, which is 2 kiloohms. If I use that in this equation, then R2 is 3/2 of R1, which is going to be 3 kiloohms. Now we know R1 and R2, that meets the requirements. It's obviously not the only solution since we're not given what I1 is exactly supposed to be. If I choose any number here that's less than 10 milliamps, I'll have a perfectly appropriate design.